To us, Earth is an endless landscape. We build lives across mountain ranges, taking months to traverse, and oceans so vast they isolate entire continents. We measure distance in footsteps, miles, and hours driven. Because we use human biology as the yardstick, our planet feels limitless. Shrink the Earth down to the size of a single grain of sand. On this scale, the gas giant Jupiter sits beside it as a large glass marble. Then there is the Sun. You could line up 109 Earths side by side to span its equator. If Earth is a single grain of sand, the Sun is a grapefruit 50 feet away. Dropped inside that grapefruit, the sand grain vanishes. Our entire world, with its oceans and histories, is swallowed up without a visible scar. Earth is not a massive world. It is a negligible, fragile speck, orbiting a perfectly ordinary, medium-sized star. Even that ordinary star quickly loses its grandeur. As large as the Sun appears from our vantage point, it shrinks to a microscopic dot when placed next to a hypergiant. This diagram maps the grapefruit-sized Sun against Stephenson 218, one of the largest known stars. If the Sun sits on the 50-yard line, Stephenson 218 expands to engulf the entire athletic stadium. Volumetrically, it would take 10 billion suns to fill this single star. Try to find Earth on this scale. You can't. A grain of sand against a stadium is so small it is physically impossible to render without drawing an artificial circle to point it out. In the upper tiers of the cosmic hierarchy, planets are functionally invisible. The universe is dominated by these massive, burning spheres of gas. Yet, despite their size, these stars are completely isolated by the empty distances separating them. If we keep our scale where Earth is a grain of sand, the fastest thing in the universe, the speed of light, slows to a crawl. It would move at just 2.4 feet per minute. This map applies that pace to interstellar travel. At that scaled-down speed, the absolute closest star to our solar system, Proxima Centauri, would be nearly 1,000 miles away, the driving distance from Baltimore to Miami. Between that grapefruit and the next nearest star is nothing but 1,000 miles of freezing, empty vacuum. That emptiness makes up almost the entirety of our galaxy's volume. Space is exactly that, empty space. The cosmos is defined far more by its dark, isolating voids than by the objects floating within it. Zooming out far enough, those empty miles begin to blur together, and we see galaxies, massive whirlpools of billions of stars, drifting through absolute blackness. These galaxies do not wander aimlessly. Gravity tethers them together, pulling them into immense hierarchical formations. Our Milky Way belongs to the Laniakea supercluster, a massive gravitational basin containing roughly 100,000 neighboring galaxies. At the largest scales, the universe resembles a sponge. Clusters of galaxies string together into glowing filaments and massive walls, forming a cosmic web that wraps around immense dark voids. Hidden within this architecture are an estimated 2 trillion individual galaxies, holding roughly a septillion stars, a 1 followed by 24 zeros. To put that into perspective, there are more stars in the universe than there are grains of sand on every beach on Earth combined. An entire galaxy, with all its nebulas, black holes, and billions of solar systems, is merely a single microscopic building block in the anatomy of the cosmic web. This visualization maps the observable universe, a sphere 93 billion light-years across, containing every detectable filament and void. But this sphere is merely a horizon. It represents the bubble of light reaching our telescopes. Beyond it, the true universe extends forever. Over 13.8 billion years, the initial fireball of the Big Bang cooled, expanded, and organized into the filament network we see today. Out there, the environment is brutal. It is an expanse of freezing vacuums, exploding stars, and crushing gravity. In a universe dominated by invisible dark matter, accelerating dark energy, and violent giant stars, a rocky little world like ours is structurally negligible. Amidst a universe composed mostly of dark energy and empty voids, our planet is a dense, highly ordered pocket of matter. In the anatomy of the cosmic web, Earth is a localized outlier.